In today's video, we're going to be multiplying and dividing numbers in scientific notation. So if we take a look at the first problem, we have two numbers in scientific notation. Okay, 3.1 times 10 to the third and 2 times 10 to the 10th. And you know what? We use the same laws that we did when we're dealing with exponents and multiplying numbers with exponents. So if we remember back when we multiplied terms, we multiplied the coefficients, kept the base, and added the exponents. The same thing goes with multiplying and dividing numbers in scientific notation. So when we do that, we multiply the numbers out in front, 3.1 times 2, which is 6.2. And then we keep the power of 10 times 10, and we add the exponents, 3 plus 10, which is 13. So the same rules apply when we multiply numbers in scientific notation. We multiply the numbers out in front, we keep the powers of 10, and we add keep the base of 10 and then add the exponents. And then we also need to make sure our final answer is in scientific notation, which this is. There's only one digit before the decimal. Okay, let's look at one with division because the same rules apply when it comes to division. All right, so dividing. I'm going to write this as a fraction, but again, well, I'll write it as a fraction form and a division form, same format, do the same laws. Okay, so one way to write this division problem is like this, or you could have something that looks like this. Oops, forgot the 8 divided by 2 times 10 to the 12. So both ways are the same way of representing dividing these two numbers. Same rules go for when we talked about dividing terms with exponents. We would divide or reduce the numbers out in front. 4 divided by 2 is 2. We keep the powers of 10. Right, keep those. And we subtract the exponents. 8 minus 12 is negative 4. Okay. And if they do ask us to convert this into standard form, we would know how to do that, right? We would just move the decimal 4 spots, 1, 2, 3, 4 to the left. So it would be 0.0002. Okay. But I'm pretty sure the problems in the lesson are going to ask for you to write it in scientific notation, not standard form. But it's still good to know how to write them in standard form. Same rules apply if it looks like this. We divide the numbers out in front, keep the base, subtract the exponents. All right. Let's look at another circumstance where we divide. Divide. Do a division problem. Then we'll do another multiplication problem, something you might see. All right. Okay. So 3 divided by 4. All right. That is actually reduced. You can't. 4 doesn't go into 3 and it's reduced, right? But we want to write in scientific notation. It's okay to have a decimal as long as it has a terminating decimal. In this case, 3 divided by 4 is 0.75. Again, you keep the powers of 10, so times 10, and you subtract the exponents. 7 minus -3 is the same thing as 7 plus 3, which is 10. And then I have my number, 0.75 times 10 to the 10th. But if you notice, this is not in scientific notation because the decimal is not after the first non-zero digit. So in order to put it in scientific notation, we have to balance out, and we have to move the decimal and balance out the exponent. So I have to move this number, this decimal, to here in order to put it after the first non-zero digit. Now, by doing that, I'm making this number smaller. So if this number gets smaller by 1 decimal spot, this exponent has to become bigger by 1 decimal spot to balance out. So my final answer would be 7.5 times 10 to the 11th power. So whenever I make this number smaller, this number has to get bigger, depending on how many decimal spots you move. Let's look at another example of that. Let's look at, we'll do a multiplication problem. And we'll throw in some negative exponents just to keep us on our toes and dealing with negative numbers. So we have 2 times 10 to the negative third, okay? And we're going to do 9 times 10 to the negative 8. Again, multiply the numbers out in front. 2 times 9 is 18. Keep the base. Keep the power of 10 times 10. Add the exponents. If you have to do this work on the side, right? We have to do this work on the side. If we're working with integers, or definitely use a calculator to do it on the side. -3 plus -8 is -11. So the exponent is -11. What's this? All right, let me fix this. There we go. Now again, this number right here is not, oops, didn't mean to move that. This number right here is not in scientific notation. So where is the decimal? The decimal is right here, and we need it to go right here. So we're actually making this number smaller. That means this number, again, needs to become bigger. So it becomes 1.8 times 10 to the negative 10th. That would be my final answer. I'll show you what happens when you get a number where the decimal actually becomes, well, we did the last one, we did where the decimal, we had to move the decimal to make the number bigger and the exponent smaller, and this one we had to move the decimal smaller and the exponent gets bigger. Okay, so you could have both different scenarios. So just double check at the end of the problem whether you have one digit before the decimal. If you have one digit before the decimal, then you are in scientific notation and don't have to adjust the exponent any further. Okay? So again, use the laws of exponents. When we're multiplying, we multiply the numbers out in front, keep the powers of 10, keep the base, add the exponents. When we divide, say I was going to divide them, we would divide the numbers in front, keep the base, subtract the exponents. With these, we try to avoid having fractions and keep decimals. Okay, so all your answers should at least have decimals, most of them, not all of them, but as you work through these problems. So if you have questions in class, please let me know. Thank you for watching today's video.